Hello everyone, welcome back to our Algebra 2 class. Today we are going to start talking about our last unit, trigonometric function. To understand this function, the very first thing we're actually going to do some review, which is actually talking about angles. So you may wonder, angle is more like geometry idea. Why do we have to talk about this in Algebra 2? Because angle is actually somehow we use it to define trigonometry function. So that's why it is very important, fundamental idea to help us to understand the trigonometry function. So to start this lesson, we are going to do a quick review. Let's just check what is angle, how they look like, how the angle look like. As you can see, many of you already still remember that angle is actually formed by two rays, right? So where the two rays intersected, we call this is the vertex, right? And also one of the ray is here, one of the ray, just basic, depends on how wide between the two rays here, then the angle can be very big, can be very small. And also, of course, we use protractor to measure the angle measurement, but this is not something we're going to focus on now. But one thing I want to remind you is, in this unit, we are not going to put angle in a random position. We actually have to define angle in a very new position, which means we are going to draw the angle on the coordinate plane. So that's like one new thing you are going to look very soon. The other is, based on, how big for the angle is, we are going to just fix one of the ray, the position of the one of the ray here, and we are going to keep moving, like rotate, like spin the other ray here to define how big or how small for this angle. For example, just imagine when you look at the clock, one of the finger is fixed, but the other finger is keep rotating. So you can imagine I can rotate this finger like this, or even like that, or even like that. Then the position, the space between the two rays here can tell me how big for the angle this, right? Like this. So that's something we're going to look at. And we call this angle rotation because you could keep rotating the one of the ray here to define how the angle position. So I know even I just have, very brief introduction here. It's probably not easy for you to understand the whole picture. So now let's just look into more details here and to understand what are the terminology we are going to look at for the angles. So in this video, we are going to look at three terminologies here. The first one is called standard position. The other one is initial ray and terminal ray. The last part, we are going to define what type of angle is actually positive angle, what type of angle is negative angle. So that's why I'm talking about, in geometry, we rarely talk about the negative angles. Because just, when we define shapes or different kind of thing, there's no way we touch on the negative angles. But since we're going to talk about the functions, we are going to touch on positive and negative angles. And just to let you know, we actually have another very, very important two terminologies, which is called coterminal angles, and the other one called reference angles. Those two terminology will be introduced in another two videos, so please make sure you check all the videos to help you better understanding of the angle we are going to talk about in this unit. So standard position, as you can see, we are looking at the xy axis coordinate plane. That's what I mentioned. We are going to draw the angle on this kind of position here. Then how do we draw this? What is the standard position? Standard position is, as you know, we have two rays for the angle. So standard position, one of the ray, I'm going to just define the positive side of x-axis is one of the ray here. And the vertex is always on the original point. So the vertex is always on 0, 0. And one of the ray is always on x-axis. And this ray, since this is a fixed ray here, and we consider this is initial ray. Initial ray is positive side of x-axis. So we always start in this position, and then we just, keep rotating for the other ray to determine how big for the angle. For example, I can just rotate like this way. This is another ray here. I can even put this ray in this position. I can even put this ray in this position. But how big for the angle? This can be, remember, you always start with the initial ray. Can be look like this and can be even bigger coming here. So all this rotation for the other ray we call terminal ray. So this position for this, they are all terminal ray, meaning where the other ray stops. Then that will tell you where exactly the position of angle is. Okay, so next is positive and negative rotation. This is how do we define this? We define counterclockwise is positive, and we define clockwise as negative. Let me write down here. So counterclockwise is positive, and clockwise is negative. This is how we define the positive or negative rotations here. With all the terminologies here, we can start drawing the angles in a different position, and we can use this position to tell us how big for the angle is. Let's check these three examples here. One thing I want to remind you is these angles in Algebra 2, especially when we talk about the trigonometry function, besides using letters to indicate angle, we also like using Greek letter, the letters you are looking at now, to define, to represent angles. For example, this one is called theta, this one is called beta. Look at 0, but remember there's a little bar in between, so it's not 0, it's theta. It's a Greek letter. We just use them to represent the angles. So we are going to draw these angles. We are going to also answer this question is identify the quadrant that the terminal ray falls in. So the first one we are going to start is 320 degree. So remember what I mentioned before, we always start with initial ray here. This is our initial ray. Where do we start? Consider this is 0, and then we're going to rotate the other ray, which is terminal ray, until we reach to the position 320. One thing I want to remind you is as we rotate, the angle is actually increasing. As we can see, this is positive, so we're definitely going to rotate like this way, right? So, but remember, when we rotate here, 90 degree, 180 degree, 270 degree, and when we come back, it's going to be 360 degree, right? But we need a 320 degree. So after this is our 270 degree position here. So after that, I need a 50 degree more, like 50 degree a little bit more than that. So definitely not going to go back. So let's rotate here. 90 degree, 180 degree, 270. So just 50 degree more. So a little bit beyond half of that. And then we can draw another ray. Do not forget your terminal ray here. And then we can just label this as 320. So as you can see, this rotation, this angle tells us, oh, this is positive rotation. And this position of the terminal ray tells us this is 320 degree. And also now let's check what is which quadrant the terminal ray falls in. So just want to remind you, the fourth quadrant is this order. As you can see, going counterclockwise is increasing to the quadrant, so that's why this is actually consistent with positive angles definition. So the terminal ray is actually on the fourth quadrant, so we are going to label here is fourth quadrant. Now let's work on the next one. This time we are looking at negative angles. As we mentioned before, we always start with initial ray. Vertex is on the x0, 0, and the positive side of x-axis is our initial ray. And since it's negative, so we know we have to rotate clockwise. So now let's see. It's going to be 280 degree. So we know this is 90. This is definitely negative 90, but this is 90. And this is 180. And then we keep going. This is 270. So 280 is a little bit beyond 280, so we're going to just go beyond a little bit because it's only 10 degree here. Don't go so wide. So, and then we draw another ray, which is our terminal ray. Remember, this angle indicate this is negative rotation, so it's negative 280. And the terminal ray here is actually located in the first quadrant, right? So this is how do we draw the negative one. Now let's work on the last one. As we mentioned, no matter what kind of angle we're working on, we always start with our initial ray on the x, positive side of x-axis. And then let's think about this. This is positive angle, so we are going to rotate counterclockwise. And also, if you pay attention to here, let's check. As we all know here, when we rotate a whole circle here, it's going to be 360 degree, right? Apparently, we still need more. One rotate is 360, so we need to rotate 100 more because 360 plus 100 can reach to 460. So we're going to keep rotating. This is another 90 degree. Of course, it's not more. It's not enough. So 10 more. So this is going to be here. So you can see, after I draw this terminal right here, you can see clearly, this is actually a whole circle rotation and plus a little bit more. So this is our how do you draw angle beyond the 360. Just keep rotating. Some students might say, can I go beyond like two circles 720 degrees? Yes, it's possible. That's what I mentioned. The angle in this unit is beyond what we know in geometry. Okay, now we have 460 degree here. And if we check the position of the terminal ray, which is actually falls the second quadrant, we are going to label here. Okay, so this is how do we draw the angles. This is just very basic to understand how do we understand the standard position of the angle in Algebra 2. When we define trigonometry function, you will see definitely more features here. So that's all I want to share with you for the first part. Do not forget, we also have another terminologies you need to understand. So please make sure to check the other videos. See you soon, everyone. Take care.